Simulation shutdown. Picture this. You're living your normal Tuesday, grabbing coffee, scrolling through your phone, maybe worrying about that work deadline. What you don't realize? Your entire existence, every atom in your body, every star in the sky, every memory you've ever had could vanish in literally the next second. No warning, no dramatic countdown, just gone. This is the simulation shutdown theory, which obviously implies that we're all living in a simulation. And honestly, it might be the most merciful way for everything to end. Here's the wild part. Philosopher Nick Bostrom made a pretty compelling argument that if advanced civilizations can create realistic universe simulations, and if they run lots of them, then statistically speaking, you're probably living in one right now. Think about it. If there are thousands of simulated universes for every real one, the odds heavily favor you being an NPC in someone else's cosmic video game. Maybe the simulation has a specific purpose, like watching how intelligent life develops. Once humans create their first baby universe in a particle accelerator, boom, experiment complete, simulation terminated. Or maybe we're just entertainment. And if things get too boring, well, even the most patient cosmic gamers eventually get tired of watching their Sims go to work every day. The terrifying beauty of the scenario, you'd never see it coming. One moment you're watching my videos, and the next, well, there wouldn't be a next. No pain, no fear, no final thoughts. Time itself would just stop. Your consciousness wouldn't even get the chance to process, oh no, this is the end, because the very concept of processing would cease to exist. Some researchers have speculated about warning signs. Maybe reality would start glitching as computing resources get diverted elsewhere. Picture stars suddenly blinking out of existence, or maybe you'd notice physics getting weird, like gravity suddenly working backwards for a few seconds before everything crashes. But honestly, a competent programmer would just terminate the whole thing instantly. Clean shutdown, no corrupted data. The really unsettling part is how completely powerless you'd be. Even if somehow you discover definitive proof that you're in a simulation, what then? You can't exactly file a complaint with technical support. You're trapped inside their reality, at the mercy of their intentions, their computing budgets, and their attention spans. There's this darkly humorous idea that maybe we should all try to be more interesting to avoid getting deleted. Keep the simulators entertained, right? But what if the opposite is true? What if creating AGI or discovering simulation theory itself triggers an automatic shutdown? The timeline for this particular apocalypse is completely unknowable. Could be tomorrow morning, could be in a trillion years. The end comes whenever our cosmic IT department decides we've served our purpose. In a weird way, simulation shutdown represents the most existentially clean ending imaginable. There would be no suffering, no gradual decay, just completion, like closing a book or turning off a movie. But that comfort comes with a price. Everything you've ever known exists entirely at someone else's discretion. And if you think that's unsettling, just wait, because the ways our universe could actually end through the laws of physics we can observe get so much worse than a simple shutdown. Heat death, also known as the Big Freeze. According to most cosmologists, this depressing marathon is probably how our story actually ends. Here's what's happening right now, whether you like it or not. The universe is expanding. Galaxies are drifting apart from each other, and all that energy that keeps everything warm and interesting is getting spread thinner and thinner. Think of it like dropping a single drop of food coloring into an Olympic swimming pool. Eventually, it gets so diluted you can't even see it anymore. The second law of thermodynamics basically guarantees this cosmic bummer. Entropy always increases, which is a fancy way of saying everything tends toward maximum disorder and minimum excitement. Over the next trillion years, stars will burn through all their fuel. No new ones will form because there's no gas left to make them. One by one, every light in the cosmic sky will turn off. If you could somehow stick around for this cosmic funeral, here's what you'd witness. First, the night sky starts getting emptier. Distant galaxies fade from view as they recede beyond the horizon. Then our own galaxy goes dark as the last stars flicker out. Planets freeze solid, and your remaining life huddles around dying embers, desperately trying to extract the last bits of warmth from a universe that's basically given up. We're just getting started with this timeline of cosmic depression. After about 100 trillion years, star formation completely stops. The universe enters what scientists cheerfully call the degenerate era. And trust me, it lives up to the name. For the next 10 undecillion years, planets might spiral into dead stars or get flung into empty space. Even worse, protons themselves might start decaying, meaning solid matter literally dissolves into radiation. By 10 duodecimane years in, black holes are basically the only interesting things left. And that's where things get really depressing, because even these cosmic monsters eventually evaporate through Hawking radiation. A regular stellar mass black hole takes about 100 viginton years to completely disappear. The biggest supermassive black holes try 10 to the power of 100 years. It's a number so large it has its own name, a googol. Eventually, even the last black hole evaporates in a final pathetic burst of light. Then what's left? Just an endless, ever-expanding void filled with a thin haze of low-energy particles holes drifting through absolute darkness at near absolute zero temperature. No stars, no planets, no life, no nothing. Time becomes meaningless because literally nothing interesting ever happens again. The universe doesn't die with a bang. Instead, it just peters out, like a campfire slowly burning down to cold ash. Except that campfire consists of everything that ever existed, and the ash is eternal darkness. But you know what? At least in heat death, the universe dies naturally, following the laws of physics we understand. What comes next makes this slow fade look almost comforting by comparison. Black hole era. You thought heat death sounded lonely? Well, buckle up, because we're about to enter the universe's most gothic phase, a time when literally the only things left alive are the universe's ultimate predators, slowly cannibalizing the last remnants of reality. Picture this. It's been about 100 trillion years since the last star flickered out. The universe has become a vast cold cemetery, where black holes are basically the only mourners left at the funeral. These cosmic monsters have inherited everything, gobbling up any stray matter that hasn't already decayed into radiation, growing fat on the corpses of dead galaxies. But here's where things get genuinely unsettling. Even these seemingly eternal devourers aren't actually eternal. Thanks to Stephen Hawking's work, we know that black holes slowly leak energy through something called Hawking radiation. They're essentially bleeding themselves to death one photon at a time. Now, when I say slowly, I mean cosmically absurdly slowly. A black hole with the mass of our sun would take about 10 to the power of 65 years to completely evaporate. That's a number so huge that if you wrote it out, the line of zeros would stretch from here to the nearest star. And that's just for a regular black hole. The supermassive black holes, those galactic monsters millions of times heavier than our sun, they're the real holdouts. We're talking 10 to the power of 100 years for them to disappear. A Google years. That number is so incomprehensibly large that there aren't enough atoms in the observable universe to write it out in full. But here's the twisted beauty of this era. You'd actually get to witness some cosmic fireworks. As each black hole approaches its final moments, it doesn't just quietly fade away. Instead, it goes out with what you could call the universe's last party. The smaller the black hole gets, the faster it radiates, until in its final seconds, it explodes in a burst of energy equivalent to millions of nuclear bombs. Imagine being an observer in this dark age, assuming any form of consciousness could even exist by then. You're floating in a universe that's essentially a black void, punctuated only by the occasional distant flash as another black hole commits cosmic suicide. Each explosion is like watching the universe's last candles blow out one by one, separated by unimaginable stretches of time and space. The really haunting part, between these rare light shows, there's nothing. No stars to navigate by, no galaxies to admire, no warm planets to call home. Just you and the dying gravitational monsters slowly shrinking in the endless cold. When the last supermassive black hole finally evaporates in its spectacular death burst, that's it. Game over. The universe enters what scientists poetically call the dark era, an infinite stretch of time where nothing interesting ever happens again. Just a thin soup of particles drifting through ever-expanding space. But at least the black hole era gives us some warning, right? A nice slow countdown to oblivion that lasts longer than we can even comprehend. What comes next makes this gradual fade look like a mercy. Big bounce. So far we've been talking about endings, but what if the universe's death is actually just intermission? What if everything we know gets completely obliterated only to be reborn in an endless cycle of cosmic death and resurrection? This is the big bounce theory, where the universe becomes the ultimate phoenix, burning itself to ash just to rise again. Here's the mind-bending scenario. Instead of expanding forever into cold darkness, the universe's expansion eventually slows down, stops, and then reverses. Everything that's been flying apart for billions of years suddenly starts rushing back together. Galaxies that were once receding into the distance begin approaching each other like cosmic traffic converging on the same intersection. At first, this reversal would be subtle. You might notice that distant galaxies aren't quite as redshifted as they used to be. But over millions of years, the night sky would start getting brighter as everything crowds closer together. The cosmic background radiation, that faint microwave glow left over from the Big Bang, would begin heating up, shifting from invisible microwaves into visible light, then into scorching radiation. As the contraction accelerates, things get properly terrifying. Stars that have peacefully orbited their galaxies for billions of years suddenly find themselves on collision courses. Galaxies merge and blend in violent light shows. The universe essentially becomes a massive traffic accident happening everywhere at once. In the final moments before the bounce, everything gets compressed into an unimaginably dense, hot fireball. We're talking temperatures and pressures that make the cores of stars look like a refreshing summer breeze. Any life that has somehow survived this cosmic compression would be incinerated long before the grand finale. Then comes the bounce itself, the moment when the universe reaches maximum compression and rebounds. According to theories like loop quantum gravity, instead of collapsing into a true singularity where physics breaks down completely, the universe hits a quantum wall and bounces back. The contraction reverses into expansion, triggering what's essentially a new Big Bang. From the outside, if there even is an outside, you'd witness the ultimate recycling program. The universe dies in a blinding flash of total compression, then immediately explodes back into existence with a fresh Big Bang. All the matter and energy gets reset, and the cosmic clock starts ticking again from zero. The really wild part is, this might not be the first time.
time. Our Big Bang could have been the bounce from a previous universe's death, and that universe could have been the bounce from another one before it. We might be living in cycle number 47, or 1848, or infinity, with no way to know how many times this cosmic death and rebirth has already happened. The Big Bounce offers something the other scenarios don't: hope. Instead of everything ending forever, it all begins again. New galaxies, new stars, maybe even new forms of life getting their shot at existence. The universe becomes immortal through constant suicide and resurrection. But here's the catch, and there's always a catch. Even if the universe bounces back to life, everything that ever existed in our cycle gets completely erased in the process. Every memory, every achievement, every person who ever lived gets incinerated in the cosmic reset. You get rebirth, but at the cost of total annihilation first. And that's assuming the bounce even happens. Current evidence suggests our universe is actually accelerating its expansion, not slowing down for a future contraction, which means what comes next might be far more permanent than any cosmic recycling program. Vacuum decay. Think cosmic recycling sounds bad? Well, what if I told you there's a way for the universe to end that makes all our previous scenarios look like gentle lullabies? What if the very fabric of reality itself is fundamentally unstable, and one day it could just break? This is vacuum decay, also known as the Big Slurp, and physicists literally call this the ultimate cosmic catastrophe. Here's a terrifying premise. The vacuum of space that our planet is sitting in right now might not actually be stable. Think of it like a ball sitting in a shallow ditch on a hillside. It looks stable, but it's not in the deepest valley possible. Given the right nudge, or just bad luck, that ball could roll over the hill into a much deeper valley. When the vacuum of space falls into a lower energy state, everything changes. And I mean everything. The fundamental forces that hold atoms together, the masses of particles, the very rules that govern how matter behaves, all of it gets rewritten in an instant. The discovery of the Higgs boson made the scenario even more unsettling. When physicists plugged the actual measured mass into their calculations, they found something disturbing. Our vacuum appears to be what they cheerfully call metastable. That's science speak for stable for now, but could collapse at any moment. Here's how it would happen. Somewhere in the universe, a bubble of true vacuum forms. Maybe it's triggered by a high-energy cosmic ray collision. Maybe it's just a freak quantum tunneling event that finally happens after waiting trillions of years. Doesn't matter how it starts, once that bubble exists, it expands at the speed of light, consuming everything in its path. And when I say consuming, I mean obliterating at the most fundamental level possible. As physicist Sidney Coleman put it, vacuum decay would be the ultimate ecological catastrophe, because inside that bubble, chemistry itself wouldn't work anymore. The very atoms that make up your body couldn't exist. From a human perspective, you'd never see it coming. One femtosecond you're here, the next you're not just dead, you're unmade. The bubble wall carries such a mess energy that you'd be incinerated before your brain could even process what's happening. Every molecular bond in your body would unzip. Every atom would fall apart, and even atomic nuclei might disintegrate. If you somehow got advance warning and could see the bubble approaching, you might catch a glimpse of a shimmering distortion racing across the sky. But that glimpse would last about as long as light travels from your eye to your brain, which is to say, you wouldn't even finish the thought, "What's that?" before being erased from existence. Now, before you start panicking, here's the good news. If our vacuum is going to decay naturally, it probably won't happen for something like centillion years. That's a number so large that calling it forever undersells how long it actually is. But here's what should keep you up at night. Vacuum decay could theoretically happen at any time. There's no countdown, no warning signs, no way to prepare. It's the cosmic equivalent of sudden cardiac arrest. Everything just stops working instantly and permanently. The bubble could start tomorrow. It could start right now, 50 million light years away, racing toward us as an invisible wall of annihilation that we won't detect until the moment it reaches Earth. Death by collision. You thought vacuum decay was bad because it could happen without warning? Well, imagine if the universe could be destroyed by something even more violent, a cosmic car crash where the other vehicle is literally another entire universe. Here's the setup. If the multiverse theory is correct, our universe is basically one bubble floating in an infinite foam of other universe bubbles. Most of the time, these bubbles expand away from each other safely, but sometimes, just sometimes, two bubbles get unlucky and smash into each other with the force of, well, two universes. Picture this nightmare scenario. You're going about your day when someone points at the sky and asks, "What's that weird mirror up there?" Because that's what you'd see. Physicist Anthony Aguirre describes it as a giant mirror appearing in the sky, reflecting light from our universe as another reality approaches at nearly light speed. At first, it might look like a strange luminous wall spanning the horizon. Then you'd realize with growing horror that this wall is expanding across the entire sky, consuming everything in its path. There's no outrunning it, no hiding hiding from it, no negotiating with it. You're about to be hit by an entire cosmos with completely different laws of physics. The collision itself would make every disaster movie look like a gentle breeze. Behind that approaching wall are physical laws that, as Aguirre puts it, wreck everything they touch. When it hits, the energy release would be so catastrophic that planets, stars, and entire galaxies would be vaporized instantly. The very atoms that make up your body might disintegrate or get forced into exotic forms that can't exist under our universe's rules. But here's the truly unsettling part. You might actually get to witness the fabric of reality tearing apart. For a brief moment, maybe seconds, maybe minutes, you could see an unimaginably intense flash as energies from the other universe pour into ours. It would be like watching the birth of a new Big Bang, except you're standing at ground zero. The really twisted irony? That mirror in the sky would show you one last reflection of our universe, everything we've ever known, loved, or built, right before it all gets erased in the cosmic collision. It's almost poetic in the most terrifying way possible. Unlike heat death or black hole evaporation, this scenario offers no gradual decline, no time to prepare or adapt. Instead of our universe dying from internal causes, it gets murdered by an external force we never saw coming. The timeline for this cosmic car crash is completely unpredictable. Another universe bubble could appear adjacent to us tomorrow, or we might be safe for trillions of years. Alan Guth and other physicists have calculated the odds as extremely small, maybe a 1% chance over the next few tens of billions of years. But in an infinite multiverse, extremely small means eventually inevitable. The worst part, if it's already started billions of light years away, that collision front could be racing toward us right now, and we wouldn't know until the moment that mirror appears in our sky. Big crunch. So far we've talked about universes that die quietly, get erased instantly, or collide with neighbors. But what if instead of any of those relatively quick endings, the universe decided to go out in the most spectacular, drawn-out cosmic suicide imaginable? This is the Big Crunch theory, where instead of expanding forever, everything that ever existed gets pulled back together into one final apocalyptic implosion. Picture this: billions of years from now, the universe's expansion gradually slows down, stops, and then reverses. Those distant galaxies that have been racing away from us for 14 billion years suddenly change direction and start rushing back. At first, you might barely notice. Maybe astronomers would detect that galaxies aren't quite as redshifted as they used to be. But over millions of years, something beautiful and terrifying begins happening. The night sky starts getting brighter. Instead of galaxies disappearing into the distance, they're approaching, growing larger, merging into glowing bands of light that span the entire sky. The universe becomes a cosmic traffic jam where everything is converging on the same intersection. Here's where things get properly hellish. That cosmic microwave background radiation, currently chilly 2.7 degrees above absolute zero, starts heating up as space contracts. First, it warms to room temperature, then to oven heat, then to furnace temperatures. Eventually, the very fabric of space becomes so hot that the sky itself starts glowing white hot. Stars begin colliding as galaxies smash together. Planets cook in their own atmospheres as the ambient temperature of the universe climbs into the thousands of degrees. Any life trying to survive this cosmic furnace would be like trying to live inside a blast furnace that keeps getting hotter. But the Big Crunch saves its worst for last. In the final years before the end, everything, stars, planets, even atoms themselves, get shredded by the unimaginable heat and pressure. The universe becomes an ocean of plasma so dense and hot that individual particles can't even exist. Then comes the grand finale. Everything that ever was, every star that ever shone, every planet that ever harbored life, every thought that was ever thought, all of it gets compressed into a single point of infinite density and temperature. The universe essentially becomes one gigantic black hole that swallows itself. The timeline for this cosmic apocalypse spans tens of billions of years, making it slower than vacuum decay or collision, but far more dramatic than heat death. You get to watch the universe actively destroying itself over geological timescales. The contraction starts almost imperceptibly, but as everything gets denser, gravity gets stronger and the collapse accelerates. The really twisted part? The final moments happen absurdly fast. Once the universe reaches a critical density, the remaining collapse to singularity occurs in microseconds. After billions of years of gradual contraction, everything ends in one instantaneous, crushing finale. At least with the Big Crunch, the universe dies in fire and fury, a dramatic conclusion worthy of everything that came before. The cosmos ends as spectacularly as it began, in an explosion of light and energy. But even this fiery death pales in comparison to what could happen if the universe doesn't just collapse, but instead gets torn apart at the most fundamental level possible. Big rip. We've covered universes that fade away, get shut down, bounce back, collapse inward, and explode from collisions. But there's one final scenario that makes all of those look like gentle goodbyes. A cosmic ending so violent and methodical that it systematically tears apart literally everything that has ever existed or ever could exist. Here's the nightmare. What if dark energy, that mysterious force accelerating the universe's expansion, doesn't stay constant? What if instead of just pushing things apart at a steady rate, it keeps getting stronger and stronger until the expansion becomes so violent that it overpowers every force in nature? In this scenario, space itself becomes an unstoppable cosmic shredder. The expansion accelerates without limit, heading toward infinite speed at a specific moment in the future, what physicists call rip time. And when that moment arrives, absolutely nothing can hold together anymore. The Big Rip gives you a front row seat to watch reality systematically destroy itself piece by piece over hundreds of millions of years. Unlike vacuum decay's instant annihilation, you get to witness the entire cosmic hierarchy collapse in reverse order. First, distant galaxy clusters lose their battle against expansion and fly apart. Then individual galaxies like our Milky Way start losing their outer stars as space stretches too fast for gravity to keep them bound. About 60 million years before the end, entire galaxies shred apart, leaving lone stars careening through an increasingly empty void. As rip time approaches, the destruction reaches our solar system. A few months before the finale, Earth's orbit around the sun fails completely. Our planet spirals away into the darkness, no longer held by the sun's weakening gravitational grip. You'd witness planets wandering off into space like cosmic refugees fleeing a disaster zone. But the Big Rip saves its most horrifying act for the final 30 minutes. At this point, the expansion becomes so ferocious that it overpowers the forces holding matter itself together. Earth, along with every other solid object in the universe, gets torn apart. Mountains, oceans, buildings, people, everything fragmenting into smaller and smaller pieces as space stretches faster than molecular bonds can resist. In the last few seconds, even atoms surrender to the relentless expansion. Electrons get ripped away from nuclei. Protons and neutrons tear apart. The very building blocks of matter dissolve into isolated subatomic particles flying away from each other at near light speed. At the moment of the Big Rip itself, the expansion rate reaches infinity. Every particle in the universe becomes completely isolated from every other particle, separated by distances that grow without limit. The universe doesn't become empty, it becomes a state where the concept of together loses all meaning. Based on some calculations, if dark energy follows this phantom behavior, we might have about 22 billion years until rip time. That sounds like forever, but remember, you get to watch the entire process unfold. Unlike heat death's gradual fade or the Big Crunch's dramatic collapse, the Big Rip forces you to witness every stage of cosmic dismemberment. The really unsettling part, the universe ends not in darkness or fire, but in absolute infinite separation. Every atom that ever made up your body, every particle that ever formed a star, gets flung apart so violently that they can never ever interact with anything else again. The Big Rip represents the ultimate cosmic loneliness, a universe where everything that exists becomes forever isolated from everything else, rushing away at infinite speed through infinitely expanding space. After 13.8 billion years of matter coming together to form galaxies, stars, planets, and life, the universe ends by tearing it all apart with such violence that even the concept of proximity becomes meaningless. And that's how our cosmos could end. Not with a bang, not with the whimper, but with everything being ripped away from everything else until nothing can ever touch anything again.